Okay, welcome back to this part about implementing the LDSO Twitch version. We will continue with the implementation now, and where we have left off is in this file, the run LDSO Twitch to mono.cc file. We have basically prepared everything, well, without those to-dos, to run the whole algorithm. That is, we have some to-dos here about the settings, about multi-threading and disable auto display and so on. And of course, the more we dive into the main function, the more to-dos we will have. And what we will continue now is to get rid of those to-dos. And the first to-do I can remove is this one here in the first line. We already added all the libraries we wanted to include here. But what is missing is, for example, here the two to-dos about the full system and the dataset reader. So we will tackle now one of these. And I think we will start with the dataset reader, because it will hopefully not require us to implement a whole lot of stuff to make it working. And we will get the first few to-dos. We will get rid of the first few to-dos, for example, those settings. So the goal of this stream is to get rid of those to-dos for the individual settings, and I think we can do this by adding all the settings that are used throughout the whole algorithm, which means that we will have some settings, some variables which we will not use at the moment, but at least they will be prepared for us so that we can use them when we need it, or when we need them. And we will see how time flies. If we can manage to accomplish the settings really fast, then we can also implement the dataset reader. But I'm not very convinced that we will do this. We'll do this in the stream. So let's try to only tackle the settings for now. Okay, so what I will do now is I will include this dataset reader file. So I will remove that. And by the way, I have this other to-do here, which I will change to note, because this is not a to-do here. Okay, so we need this DatasetReader.h file. And in the... Oh, thanks for the follow. That's nice. Thank you. Yeah, what we will do now is we will create this file, this DatasetReader.h. So I will copy that, and in the original LDSO code, it is placed, so the DatasetReader.h file is placed in this example folder. I believe that this is not very nice. I will place it in this include directory that we have to create first. So I will create a new folder here, and I will call it include. And in this include folder, I will create a new file, which will be called DatasetReader.h. Okay, so this is the DatasetReader.h file, and we can see that the error is gone, and that this should work. Now, the dataset reader is, yeah, it is quite not very complicated, but it has a lot of lines of codes. So I will skip this dataset reader logic, and I will now include the next file, which will be called Settings.h. And in the Settings.h file, there will be all the variables that we need to access here. So for example, this desired image density, desired point density, and so on and so forth. Now this is not working because, for one, we do not have the Settings.h file. So let's create it in this include directory as well. Settings.h. And next, we also want to have some include guards here. So let's take a view. Let's take a look. We start with if not defined, if and def with, of course, the hashtag LDSO, and then let's say Twitch DatasetReader.h. If this is not defined, then we define it same. And of course, in the end, we also want to close that if, writing and if LDSO Twitch DatasetReader.h, but it's sufficient to write and if. So let's comment out the last part of this line. Okay, so this works so far, it seems. Now let's quickly try to compile that with these changes. I'm here in my directory, LDSO Twitch, and I can now make the project. We have some warnings, but it's fine. And now we will run the program. Therefore, we have the script run LDSO Twitch sequence.sh, and we do not have a segmentation fault or something. We finished or can exit as usual, so this is still working. What we have to keep in mind though is that I did not save, but I think it's okay. And we have also to keep in mind that we need to add our implementation files like the feature.cc here in the cmakelist.txt. But at the moment this is not necessary because we only have header files which are included in this main cmakelist text file, which now points here to the include directory. So this should be fine. No changes necessary at all for now. But we will have to update not this file, but at some point we have to update this file and yeah, pay attention to it. Okay, let's try to now add some of the settings which I used here. So for example, we have the first specific setting. For example here, which is called setting desired image density. So let's go to the Settings.h file and let's put it here. Let me quickly check. Yeah, now we have one specific namespace here. For example, using namespace LDSO. I think I will leave it with LDSO, I think. Just not to deviate too much from the original code base. So let's use it here. And in the Settings.h file, We are missing the include cards as well. If not defined, LDSO Twitch Settings.h. Then we want to define it. And next we define namespace, which is called LDSO. So the namespace is useful for us to avoid collisions of variable names, especially if they are global variables, like in this case. We might have situations where variables are named identically, but mean different things semantically. So we need to usually wrap it in this namespace. And next we also end the if, and also add this name for reference. Okay, now let me quickly look up what kind of data type this is in the original code. Okay, so this will be an extern float. And this is one example. Now the settings.header file will also have an implementation. This is because we will have specific settings that we need to add with some logic. I'm specifically talking about what is called a neighbor pattern, or the residual pattern here, which needs to be an array, a multidimensional array, which needs to be initialized. And this can only be done, as far as I know, in the in the implementation file, so in the CC file. So let's go ahead and create this Settings.h file for the implementation, so the Settings.cc file. I will right click here on the source, new file, and I will say Settings.cc. Fun fact, in the original code base of the LDSO, this is not called Settings.cc, but it is called Setting.cc. Okay, now that we have this implementation here, we need to add this to our cmakelist.txt file, as we did with the feature.cc. So we'll open the cmakelist.txt, and just as I have this feature.cc file, I will also add the settings.cc file here. So we need to keep track of if we have added all of our implementations, and there will be a lot of files in the end. So yeah, we need to pay attention, as I already said. Okay, settings.cc and settings.h. Now, there are a lot of settings, and I thought a little bit about whether I should write them down one by one or just copy and paste them. But just for learning purposes, I would say it's okay to write them down, even though it will take time. But by writing them, we have enough time to think about the meaning of these. Of course, many of the final reasons why we have specific settings will be clear with the final implementation and when we are actually using them, but we will get a short glimpse on what kind of settings we have and how complex the whole system can get. So I will say that it is probably a good idea to write them down one by one. Okay, so let's go to our Settings.h file. Yes, we are here. And let's start with writing down the parameters. And even the original code base has a comment with many parameters set in DSO. I will change this original comment to LDSO and to a lot of parameters can be set in LDSO. Now we start with two constant integers. The first one is pyr levels equals 6. And this is the total image pyramids. Note, not all are used during the tracking. So what image pyramids are, these are basically scaled down versions of our original image. So we have one image which is in full HD, for example, and we scale them down usually by half. And if you imagine this graphically, you will see it's an image pyramid. Okay, next we have also a constant integer about the number of threads to use. Next we have the config bits in the solver. The solver is the very important part that tries to estimate the required parameters, such as when we have two images, want to estimate how did the camera move in between those two images. So the solver is the estimator that is solving for the parameters we want. And here are some specific settings, and this is given as bits, so as a bit pattern. The first one is a constant int for solver svd equals 1. So we can imagine this as an 8-bit pattern. 4, okay, and we set the first bit, for example, like this. Next setting is int solver, then orthogonalize system equals 2. And this can be imagined as being this bit pattern. And later, when the system is being used, or also in the Settings.cc file, you will see that we can combine those, for example, those two settings with each other, and then we get a bit pattern which is similar to that, but is combined with an AND operator, for example, and will then result in this bit pattern if we combine those two bits. Okay, I will try to leave out these explanations, but from time to time, as far as I understand something, I can of course explain it, and I will try to do that. Okay, so let's continue with const int, and maybe we can now really copy that. The next one is solver, and then orthogonalize as well, and point mark. The next one is full. And those are the 3 orthogonalize methods. Next one is 8, I mean. So you can see that with every new setting or with every new solver option, we'll get one of the next bits here. Okay, so next we have orthogonalize. No, we do not have orthogonalize, but we have SVD cut 7, which is then 16. And next we have remove pose prior, which is 32. Then we have solver use GN, where GN probably stands for Gauss-Newton, which is one optimizer method. Then we have fix lambda. Then we have orthogonalize again. Orthogonalize X. Oh, it's wrong. It's allies. Orthogonalize. Then we have 256. Then we have momentum, which is 512. Then we have step momentum, which is 1024. And we have one other orthogonalize X later, which is 2048. And that's it with the solver settings. So yeah, a lot of parameters used in the actual solver, which we can hopefully discuss at some point. Next we have constants to scale their parameters in optimization, which is, for example, a float. Scale I depth equals 1.0f. And there is an explanation in the original code which tells us scales internal value to I depth. And we have another float, scale xi rot, which probably stands for rotation, but there is no explanation here. So I will add rotation here. Next we have, when we have rotation, we also have translation. If I can type. Oh, it's only trans. And this is weirdly 0.5. And here is where the magic numbers come in. So I have no idea why this was chosen the way it was. But the main problem is that with our Visual Slam that we are implementing here, we usually have one big problem, that is we do not know absolute values. So we do not know, for example, how far the camera has moved in meters. So we always have to normalize the initial estimate. And here those values can be chosen to scale those internal values, and most of them will be 1 anyway. But there are also values not equal to 1, such as the f, which is equal to 50. And the C as well, scale C. But scale W is then 1 again. Scale A is 10. And scale B is 1000. No idea why that is. But I would say that F, I think, is focal length. I think C is principal point. No idea what W is. And A is, I think, one of two, this is called photometric parameters. And B is basically the second parameter. Okay, next we have the detail setting variables. And the first one is extern int parameter levels used. Then we have extern float setting keyframes per second. This is, by the way, one setting that was mentioned in the original DSO paper, where they say that they try to add many keyframes in the beginning of the operation of the LDSO and less later. Extern bool setting real-time max keyframes kf. Extern float setting max shift weight t. Which is probably again translation, because we have one with the max shift weight r, which is rotation, and then we have one with rt, which is probably rotation plus translation. Then we have an extern float setting max affine weight. And we have an extern float setting kf global weight. An extern float setting I depth, which probably stands for inverse depth, fix prior. And we also have this fix prior and then mark fac, marginalization factor probably. And then we have a setting for the initial rot prior. And of course we also have a trans prior, a translation prior. And we also have an FB prior and an FA prior, which should be related to this A and B here. We'll quickly switch that. So A and B prior. Oops, I'm sorry. Then we have an extern float setting initial calibration. Then we have an extern int setting solver mode. Then we have an extern double setting solver mode delta. Extern float setting min I depth h act. Then extern float setting min I depth h mark. Extern int setting mark point this window. What is the problem here? Extern double setting. Oh, I see. Should be an underscore. So mark point this window. Next we have the extern float setting max I depth. Extern float setting max pix search. Extern float setting desired. Here we are with the desired image density that we need here. Then we have our extern float setting desired point density. Here are some comments which tell us that this is done. I don't know why this comment is important, but I will add it as well. The thing is, probably this is called done because this setting is already set in the main function. So if we look here, for example, here the setting desired image density and desired point density, they are set here. So that's why I think this is marked with done here, but I'm not sure, to be honest. Next we have extern float setting min points remaining and extern float setting max log f fac in window. Next we have an extern integer setting min frames. And if we have min frames, oops, an underscore is missing. Then we have max frames as well. And we also have a setting about the min frame age. We also have a setting extern int setting max opt iterations. I think this is also set in this main file, like here. So if we have this max, then we also have a min. Okay. Next we have extern float setting th opt iterations. Then we have our outlier th, which is probably the threshold for the outliers. One of the thresholds that is possible. Setting outlier th. Then we have outlier th sum component. And we have our outlier smoothness threshold. And here there's a comment with higher means more strict. Whatever strict means here. Strict about the smoothness. So this is the main problem of the visual slams. They have settings all over the place, and often it's just tweaking one or the other setting for a specific data set, but not in general, I would say. But maybe, I don't know, maybe there are settings which solve specific behaviors for every data set. Extern int setting kill overexposed. Okay, probably overexposed images which show no detail. So we also have an overexposed mode here, which is an integer. And we have an extern integer setting pattern. And in my view, this is not from the original code base. In my view, this is one of 10 implemented patterns. Let's call them residual patterns. See below. This will be added below in a minute. Maybe not in a minute, but maybe in a few minutes. Okay, setting pattern. Setting pattern. Next we have an extern float. Setting mark weight fag. And we have an extern int. Setting discrete. So, oh. Okay, it's written in the original code is written such. It's on point activation. Now I'm not sure if we should fix this because it's probably search. But then we have to think more when we implement the rest. And this is error prone. But I would say I will change that. Somehow it bugs me. Change it by Langwasser TV. Extern int setting discrete search. It's on point activation. Discrete search. Discrete search makes sense, yeah. Okay. Extern int again. Setting Gauss-Newton. It's on point activation. Next we have extern float. Setting smoothness error pixel threshold. Extern float setting smoothness e min inlier percentage. And we also have this E good inlier percentage. Okay, I'm not sure what this E is. I hope it's the essential matrix, but I'm not sure. As with many things here, as you already noticed. Okay, where's the music? Yes, I want to continue. Okay, E good inlier percentage. E good inlier percentage. Then we have extern float setting min trace quality. Then we have extern int setting min trace test radius. Min trace test radius. Yes. Extern float setting retrack threshold. Extern int setting min good active res for mark. Extern int setting min good res for mark. And extern int setting min inlier votes for mark. Then we have extern float setting min rel bs for mark. BS. It's not baseline probably. Min rel bs for mark. Extern int setting photometric calibration. Okay, this is probably also included in this main file. Photometric calibration. Here, photometric calibration will equal 0. And nothing else, probably. Okay, setting photometric calibration. We're halfway through this file. So let's continue with the extern bool setting use exposure. Extern float setting affine opt mode A. And if we have a mode A, then we also have a mode B. And for both of these, we also have what is called a Huber.th, probably a Huber threshold. And next we have extern int setting gamma weights pixel select, and extern bool setting rel in always, probably rel in always. Then we have extern bool setting fix calib, extern bool setting activate all on mark, extern bool setting force accept step, accept, maybe accept step, because otherwise I'm not sure what this means. So I will add a comment from me. Maybe it should be called accept. Because when we are talking about optimization, we are optimizing in steps with different step sizes. And at some point, we need to accept or discard this current step. So I'm not sure. Let's leave it like that. We do not want to break anything by choosing a different name. I'm pretty sure that even though I have tried to type everything as the original code base, there will probably be some typos. And I hope we can fix that at some point, but that's the danger with typing it all one by one. But I think we can fix that if necessary. Okay, force accept step. Then we have an extern float setting, use depth, weights, coarse. Then we have an extern bool setting, dilate, double, coarse, extern float setting, uber.th, and extern bool setting log stuff. And there's a comment in the original code base which says whether to log. Yeah, makes sense. Extern float benchmark. There are a few benchmark settings. Benchmark setting fx, fy, and fac, which is a float. Then we have two ints. Int benchmark setting width and height. Then we have two floats again. Benchmark setting. No, it's called benchmark underscore var noise. And we also have a benchmark var blur noise. I think this might be probably some leftover from internal testing at TUM. They probably had to benchmark the algorithm somehow, and I'm not sure if this is used here. We will see. Benchmark noise grid size for lowercase s. And last benchmark is extern int. No, excuse me. This is a float, and the one before the grid size was an integer. Here we have benchmark initializer slack factor. Benchmark initializer slack factor. Okay, but that's it with the benchmark settings. Next we have an extern float setting frame energy, th const weight, and some other energies. Frame setting frame energy THN, frame energy TH fag mean, and also a fag median. And then we have not a frame energy but an overall energy TH weight. And we also have a coarse cut off TH. Then we have an extern float setting min grad hist cut, extern float setting min grad hist add, and extern float setting fix grad th. Okay. And then we have an extern float setting grad down weight per level. Grad down weight per level. And an extern bool setting select direction distribution. An extern int setting pixel selection use fast, extern float setting trace step size. Then we have, what is wrong here? Step size. Okay, nothing. Extern int setting trace. Then we have GN, Gauss-Newton, I believe, iterations. Then we have 4 floats. Oops. Okay, well, the first float is trace GN threshold. Then we have trace extra slack on TH. Then we have slack interval. And we have lastly the min improvement factor. Let me make this music less noisy here. Okay. Min improvement factor. Min improvement factor should be fine. Let's save that. Okay, next we have extern bool setting render display coarse tracking full. I believe here are some settings for the 3D viewer. display course tracking full. These are bools. Let's copy them. Setting render. Then we have render window frames. Then we have plot tracking full. Render display 3D. Then we have a display residual. Then we have a display video. And we have a display depth. Okay, and then we have a setting full reset requested, which is basically also for the 3D viewer, but related to a general setting. So I will add a new line here. Okay, setting full reset requested. We are getting there. And then we have another bool, extern bool setting debug out run quiet. And we have an extern bool setting setting debug out. No, we have no setting, but we have a disable all display. Next we have an extern bool disable reconfigure. Then we have an extern bool setting again, only log kf poses, the keyframe poses. So we have frames and keyframes, and this will only log the keyframe poses, I believe. Extern bool debug save images. Then we have extern int sparsity factor. Extern bool go step by step. We have an extern bool plot stereo images. And we have an extern bool multi-threading. And then we have an extern float free debug param 1. And we have 5 of them. 2, 3, 4, 5. Next we have an extern int. Oh wow, this is a Ludum Dare stream. Well, maybe. It's not for game design, but it's more for robotics. But yes, you could say it's a Ludum Dare. But I do not have a time limit. So I will try to do it as quickly as I can, but yeah, you're right. Thanks for the comment. Extern int. Then we have a benchmark. Special option. What does LDSO stand for? LDSO stands for Direct Sparse Odometry with Loop Closure. You can look it up here. Let me quickly do that. New private window. LDSO, GitHub. So, this is actually not the right result. Let's see what is written here. So this is the LDSO, direct sparse automatic with loop closure, and there should be the GitHub repository somewhere. Let's go to GitHub and search for LDSO. Not a user, come on. Yeah, now you can see in TUM Vision /LDSO, you will see the LDSO here. Oh no, LD was not folded on there. Yeah. No. Okay, let's continue with benchmark special option. That's it. Then extern bool setting pause and extern int setting point selection. And here from the original code, it's written 0 is DSO. DSO's selection. So DSO is the predecessor of the LDSO. It's direct sparse autometry. Then 1 is LDSO LDSO's selection. And we have also the option 2, which is a random selection. Okay, now we are almost finished with this file. It's about time. Const int pattern num equals 8 and const int pattern padding equals 2. Now what are those patterns? Patterns see Settings.cpp. And this is wrong because this will not be a Settings.cpp, but it will be a Settings.cc file. And in the original code base, there was no Settings.cc, but a Setting.cc file. But this will be correct here. And we have 3 extern ints, which are arrays. So we call them static pattern. And those are 3-dimensional arrays, where the first dimension is 10, the second one is 40, and the third one is 2. Then we have a static pattern num, which consists of 10 elements. It's a 1D array. And a padding, which also consists of 10 elements. Static pattern num and static pattern padding. Okay. Next we have the important setting for loop closure, or loop closing setting. Whether to use loop closing. If set to false, the program runs as original DSO and it's enabled by default. And this is the setting. The setting is extern bool setting enable loop closing. Okay, next we will have another option which is called fast loop closing. If this is enabled, not all the keyframes in DSO will be corrected, and we will also have less constraints. Note, if you don't enable fast loop closing, you would probably wait a little time for the pose graph, probably. Pose graph optimization, of course. And the loops will not be immediately closed after detection. So we could say that this is the normal loop closing is a post-processing step, and the fast loop closing is more like a real-time post-graph optimization. That's what I understand from this description. And we will see this in action, of course. Extern bool setting fast loop closing. And as a last setting here, we will have whether to show the loop closing. If true, will show the loop keyframes in a let's call it like that, OpenCV window. This is only for debugging and for plotting when writing a paper. Of course. Extern bool setting show loop closing. And then there's a define here, which tells us that we want to use a specific pattern. Use the 9th pattern described in DSO's paper. So we have a define here. For a pattern P, static pattern 8. So instead of writing static pattern 8, we just define a pattern P name, and this is a shorthand. Okay, so that's it. That's it with the header file. But if you have thought that we are finished now, you're wrong, because of course we need to set all of these settings for initial values. So we have to do all of that once again in the implementation. So I'm sorry, but this is how they designed it. And we can see that there are a lot of parameters, a lot of settings which we can set, which will do different things when running the LDSO. Yeah. I'm not sure what I can do with this information now, so if we will try out everything, I'm not sure, but let's finish the code for now. I'm happy that I finished the Settings.h file. And now let's go to the Settings.cc file. Okay, let's see. Maybe we can copy all of the variables here. And then delete parts which we do not need. Before I do that, I want to include the Settings.h file. Include Settings.h. And I also want to include the C standard input-output. I'm not sure why. I think we can delete that later. Let's add a to-do. And we want to use the namespace, which is LDSO. Using, no, wrong, sorry. We want to use std. And we want to define the namespace here. Okay, now let's paste in all of the settings from the header file. And let's go through them. It's probably not a good idea, but let's get rid of the permit levels and the solver and the scale. So all of the variables that have been initialized already, we can delete them. And now we need to set the remaining variables. So here's an int permit levels used. This will be set to the constant per levels. Okay. Keyframes per second will be 0 in the beginning. And the real-time max keyframes is false. Okay, that have been the easy parts, the easy bits. Next we have those weight settings here. And these are set to 0.04 float times 640 plus 480. Why? No idea. These are the magic numbers, which is the same for the rotation, but the rotation is actually 0.0f, which is 0, times something equals 0. But probably the 640 and 480 are related to the width and height of our input data sequence or image sequence, and therefore it probably makes some sense to include this here. RT equals 0.02f times 640 plus 480. And this is about the weights. Now we have the max affine weight. This is not sorted the same way as in the original code. So I need to think a little bit. Sorry about the mic. KF global weight is 1.0. Then we have the inverse depth fix prior, which is equal to 50 times 50. Then we have the fix prior mark fec equals 600 times 600. And there's also a comment which tells us that this could also be 30,000 times 30,000. Then we have the rotation prior, which is 1e11. 1 times 10 to the 11. And then we have the translation prior, which is 10 to the 10. Then we have the affine A and B, which are both 1e14. Then we have the calipation, which is 5 times 10 to the 9. Okay. Now for the settings solver mode, we can use our bit patterns that we have defined and say settings solver mode equals solver fix lambda or solver orthogonalize x later. So it is not like I said before that this is an AND here to combine them, but it's an OR, of course. Okay, then we have a solver mode delta is equal to 0.00001. Then we have the min I depth h act is equal to 100. Then we have marginalization set to 50. And the mark point with window is 0. Okay, let's now get rid of those extern keywords here. Okay. Now, this setting is missing, it seems. Let me quickly check. Yeah, this is missing. So I will comment out this setting for now. Let me check if this is set here. Oh no, it's probably not, because otherwise we would have it here initialized. This is something we need to watch out for, because if the max eye depth is not set, this could lead to problems. Okay, but let us not be confused about that, but just continue. Setting max pick search. This one is set to 0.027. Then we have a desired image density, which is usually 1500. And we have a desired point density, which is usually 2000. Then we have min points remaining is 0.05. And this log f vac in window is 0.7. Okay, let us now continue with the min frames. So this is, as far as I can see it, the number of frames in the optimization window, in the sliding window. And this is set to 5. And the max frame is set to 7. And the min frame h is 1. The minimum optimization iterations is equal to 1. And the maximum optimization iterations is set to 6. Okay, now we have the setting for the threshold of the optimization iterations. And this one is set to 1.2. And the outlier threshold is equal to 12 times 12. The smoothness threshold is equal to 0. And the threshold for the sum component is equal to 50 times 50. Okay, and now we have some explanations here as well. The outlier threshold is the same comment as here. Higher means more strict, and this component also means higher, more strict. But here in the th sum component we have an explanation which means higher is a less strong gradient based reweighting. So the image gradients are important parameters or important information which we use for the optimizer to move it in the correct direction that we want to optimize. Okay, then we have an integer setting kill overexposed equals 1000 and kill overexposed mode equals 0. And then we have a setting pattern, and this is equal to 8. Then we have an extern float setting mar weight vac is equal to 0.5 times 0.5. And then we have the setting discrete search, its on point activation is equal to 0. Let me comment this as well here so that I will know later what was changed. On point activation. Then we have Gauss-Newton. Its on point activation is equal to 3. Okay, then we have the smoothness. floats, and the smoothness error pixel tn is equal to 1000. And the min inlier percentage is 0.25. And the good inlier percentage is 0.66. Then we have the min trace quality is equal to 3. And the min trace test radius is equal to 2. Okay, test radius. Okay, then we have the retrack threshold, which is equal to 1.5. And the residual for marginalization is equal to 3. The good residual for marginalization is 4. And the min inlier votes for March is equal to 0. And the min rel BS for Mark is equal to 0.00 even. But we have some comments here which tell us irrelevant. So we probably do not need to pay attention to these settings. But we want to ensure that nothing breaks, so we will add that here. Okay, now we have the photometric calibration, and here's a comment which tells us that 0 is equal to nothing, 1 is equal to apply inf response, and 2 is equal to apply inf response and remove v, which is very cryptic. But as far as I understand it, it's the inverse response is basically our gamma correction. So if we have a gamma curve that is given here, let's make it concrete. So what I mean is we have this data set here, we have the photometric calibration here in this text file, and in this text file we have values from 0 to 255. So this is basically our gamma correction. And we just want to apply the inverse of that to correct the images. And we also have this vignette image here, which looks like that. And if we take that, then we want to use this vignette image as well to correct the image. And this means we want to remove the vignette. So the photometric calibration can be set to those 3 values. And we set it to 2, of course, because we suppose that we have a photometric calibration given, and therefore why not use it with the inverse response and the vignette. So this is probably vignette. I'll write it out. Vignette. So this one here is gamma, and the other one is the vignette. Okay, so far so great. Next we have the bool setting use exposure equals true. And then we have the float affine opt mode A. And this is equal to 1e12, so 1 times 10 to the 12th. And for the mode B, we have 1e8. For the Huber threshold for A, we have 10,000. And for B, we also have 10,000. Okay, we are getting there. Next we have the integer for setting the gamma weights pixel select. This is equal to 1. Then we have the setting rel and always, which is true. The fixed calibration is false. Now the question is, what kind of calibration is meant here? Is it the geometric calibration or the photometric calibration? And I would say, or as far as I understand, it's the photometric calibration which is meant here. And the geometric calibration will be fixed. But we will see that, hopefully. Next we have two other bools, which is setting activate all on march. And this is false. And this one is true. Okay, force accept step. Next we have the setting use depth weights coarse. And this is equal to -1. Then we have the dilate double coarse, which is equal to false. Then we have an setting Huber.th and setting log stuff. So the th is equal to 9. And the log stuff is not available in the original code, it seems. Oh, it is. But it is set later. So let's just keep it here. This is equal to true. And let's return to the Huber threshold. Huber threshold is 9. Then we have the benchmark settings. This is scattered all over the place, but this one is 0. They are probably all 0. Setting width height is 0, var noise is 0, var blur noise is 0. Now the noise grid size is 3. And the initializer slack factor is 1. Okay. Next we have the frame energy const weight. This is equal to 0.5. Frame energy THN is equal to 0.7 F. The mean is 0.0. And the median is 1.5. And the threshold is 1. And the cutoff threshold is 20. And the hist cut is 0.5. And the hist add is 7. And fixed grad th is -1. Fixed grad th. Okay, let's get rid of the extern keywords here. Alrighty. Quite a lot is missing still, so let's continue with the setting grad down weight per level, because this is 0.75. The direction distribution is true. The selection use fast is 0. The trace step size is 1.0. The Gauss-Newton iterations are 3. And we have the Gauss-Newton threshold is 0.1. The extra slack on TH is equal to 1.2. The slack interval is 1.5. And the min improvement factor is 2. Now we'll add some explanations to the lower part. But first I will remove the extern keywords again. So the explanation of the Gauss-Newton threshold is, no, wait a second, of the step size here, I mean, is step size for initial discrete search Next we have the trace Gauss-Newton iterations is equal to 3. This means maximum number of Gauss-Newton iterations. Who would have thought? Then we have the Gauss-Newton threshold, which means Gauss-Newton stop after this step size. Then we have for energy-based outlier check, be slightly more relaxed by this factor. Extra slack on TH is a relaxation factor. Okay. And the other two settings mean if pixel interval is smaller than this, leave it be. And this is the same for the improvement factor. What is this? Is smaller than this, of course. Okay. Next we have we need to jump a little to the free debug param, because these are all equal to 1. Like this. Then we have disable reconfigure. Where is this? Disable reconfigure. Sorry, I need to jump a little bit because it's organized differently in the original setting or in the original code base. So this disable reconfigure is equal to false. Then disable all display is also equal to false. Debug save images is equal to false. Then setting only log KF poses is equal to true. Sparsity factor is equal to 5. And go step by step is equal to false. plot stereo images is cannot find it. Let me check if this is defined. No, this is not defined in the original code base. So we will leave it out here. What is missing? Setting debug out run quiet. Okay, this is set to false. And full reset requested is also false. And multi-threading is true. It's equal to true. Okay, now what about the 3D viewer? Here we have display course tracking full is equal to false. Render window frames is equal to true. Plot tracking full is equal to false. Display 3D is equal to true. Display residual is equal to true. Display video is equal to true. And display depth is equal to true as well. Which is weird because the depth is not shown when the LDSO is running. So I'm curious what is wrong here. Okay, but for now we can leave it like that. And now let's go to the last part here, which is benchmark special option. This one is equal to 0. Setting pause is equal to false. And setting point selection is equal to 1. Of course, we want to use the point selection method from the LDSO. Okay, this is about this part. Pattern num. I think pattern num was set in the header file. Yes, so we can delete that from the CC file. But we need to set the loop closing variables here. So let's move them up. And let us delete the comments. So this one, these ones are true. Loop closing, we want to enable that. We also want to have fast loop closing, but we do not want to show the loop closing. Okay, now we have a method here, or a function rather, which is called void handle key. It's weird to have that in the Settings.h file, but okay. Now, first we want to store a char, which is called kkk equals k. So this is probably the key that was pressed. And then we want to have a switch statement where we check the pressed key 4 different cases. So the first case you want to check here is the key D in lowercase and in uppercase as well. If the key D was pressed, then we want to set free debug param number 5 to int. We want to cast it to an int. Take the free debug param 5, add 1 to it, and then we take everything and compute the modulo of with 10. Modulo 10. And now here comes the standard input-output library, which I would like to change due to consistency to the cout. Cout. Then we print new free debug param 5. Then we add the free debug param 5. And then we add an end line and a break. Using namespace std, and I want to change that. Let's comment out this one. And let us include the IO stream. Okay. Let's turn on the music again. Okay, free debug param 5 break. And we also have the same, but with S, small s and capital S, free debug param, and this will be -1 plus 10. Which is very weird, but okay. New free debug param 5. And we have no default, but I will leave that here. Okay. Now, after this handle key function, we will add our static patterns. So for the static patterns, we need to know that we have 10 kinds of patterns. And as you will see, a -100 means not used. And as far as I understand it, the -1 stands for a direction. A direction, how we move from one pixel to the next pixel. So let's say -100 means pixel direction is not used. It will get clear in a second what this means, but let's now add the static patterns. And as you can see here, we have defined a static pattern array, which is 3-dimensional with 10 elements in one direction, then 40, and then 2. So the 10, maybe I will, let's document that somewhere. Let's remove this comment. Let's remove this extern keyword here. And let's open up the definition. So we can say here that 10 patterns or 10 kinds of patterns. Then we have dimension 2, which means we have 40 kinds of directions. And dimension 3 means that we have two 2D vector, 2 dimensions of movement direction. So usually delta x, delta y. That's how far I understand it. This is not included in the original code base. This is written by myself. But what is included in the code base is the following. It is basically a drawing of the pattern. So we have this bar here, underscore bar. And this represents a pixel location. So we have a grid of pixels in our image, like this. And the first pattern we define here consists of only this pixel in the center. So if we are currently at this location, we want to move in the direction delta x equals 0 and delta y equals 0 to stay at this location. And this is defined in a cryptic way when you see it for the first time, I would suppose, like this. So you have this array of arrays, which defines a 0, 0 here. And the rest that is defined here consists of many entries which show us here a -100 and a -100 here as well. So as we have 40 of those patterns, we should remain with 39 of those not used kind of patterns here. So this means not used, and we define one pixel that we want to use here, which is at the center point, and the other ones, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I think I did not count well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's fine. So those are 10 here. This should be 30. And now we need one less. And in the end, we need a semicolon. No, we need a comma. Okay, so this is a definition of one pattern, which should be this one here, which means that the current pixel, which you can imagine as being in the center, is not moved at all, and the other ones are not used. So we just take this central pixel here and not the other ones. These residual patterns do have an impact on the operation of the LDSO, because they provide us information about the neighborhood in an image, and this neighboring pixels can be used for further for further check whether or not our optimization has reached a minimum. I hope this is somewhat clear. In fact, we can use different kinds of patterns, and there's only one of those patterns used in the LDSO, but the other ones are used for completeness. So I will also add them here. So let us comment, this is the pattern 1. And we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's rename that here. 4, 5, 6. And this is not included in the original code base, this pattern, but actually the images are. So 8, 9, and this is number 10. Okay, let's go to the second pattern, which is designed like this. So it's basically just a cross. Like this. So this means we want to go of course we want to have the central pixel as well, but we also want some other pixels. We have 5 in total, and the first one we could say is stay in the x direction but go one down with -1. Then we also want to go left. We want to stay in the center. We want to go right, and we want to go up. Now, of course, I have to remove 4 of here, 4 of them. This should be okay now. The error is gone. Okay. So this is the second pattern. Now we have the third pattern. Which is more like an X shape. Now here we have 5 pixels again, so I add 4 more. The first one is the lower left corner, and it could be that I'm mixing up the coordinate system, because I'm currently thinking about the coordinate system being arranged like this. So here, now we have here the x-axis, and here we have the y-axis. But it could also be that it is flipped depending on how we read in the image data, and it could actually really be flipped along the y-axis. So keep that in mind, that I'm only using this for visualization here, and it's not necessarily the way it is implemented. So this strongly depends on how you read in the image data and how the image data is defining the rows and columns of the individual pixels. And this can differ. Okay, so this is the X pattern, and we move it diagonally to the left, lower left, by specifying -1 and -1. Then the lower right, the upper right, I mean, 1, 1. Then we have the central pixel. Then we have -x but +y for the lower, for the upper left. And we have +x and -y for the lower right. Okay, I think we need to delete 4 elements of here. And then it should be fine. Now the other patterns do not have those nice pictures. So let's quickly think if I try to do it on my own here. Okay. I think I can try it. So now let's add 1, 2, 3, 4, 5, 6, 7, 8, 9 elements here. And let's remove 8 from here. So these are 4 and 4. So this should be fine now. Okay. And the pattern goes like this. -1, -1. Then we have -1, 0. Then we have -1 and 1. Then we have -1, 0. Then we have 0, 0, then 0, 1. Then 1, -1. 1, 0. And 1, 1. Okay, so let's see. -1, -1 would be this one. -1, 0 would be this one. -1, 1 would be this one. Oh, we have 2 times -1, 0. That's interesting. It's not my fault. Then let's add it twice here. I don't know what to do else. So, okay. Interesting. There's an error here. But this is not used anyway, so maybe we should not spend that much time on that. But let's finish it. -1, 0. Then we have 0. Then 0, 1. Should be this one. Then 1, -1. Should be this one. 1, 0. And 1, 1. So this should be the final pattern with this just once here, usually. Okay. Let's now go to pattern number 5. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 6, 9. Yeah, that's correct. The first is 0, -2. Then we have -1. And once again -1. Then we have 1, -1. -2, 0. 0, 0. 2, 0, minus 1, 1, oops, minus 1, 1, then 1, 1, and 0, 2. Okay, so now we have 9 elements here, so we need to remove 8. That's 4. And 4 again. Okay, so here, the interesting bit is that we are using a broader pattern, which tells us that we want to... Oh, that's the wrong axis. So we have this vertical movement to -2. So this is this one. Then we have -1 and -1, should be this one. Then we have 1 and -1, which is this one. Then we have a -2, should be here, and 0. Then we have 0, 0. Then we have 2, 0. Then we have -1, 1. This one. And then we have 1, 1, which is this one. And then we have 0, 2, which is this one. So this is the full like 3x3 pattern rotated 40 degrees, 45 degrees. Okay, pattern 6. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10. And 3 more. 11, 12, 13. We need to delete 12 here. So 4, 8, 10, 12. This should be fine. Okay, now the pattern is as follows: 0, -2. Then we have -1, -1. Then we have 1, -1, -2, 0, 0, 0, 2, 0, -1, 1, 1, 1, 0, 2, -2, -2. Then the other 3 are -2, 2, 2, -2, and then 2, 2. Okay, so once again we have more columns and rows. Okay, so now we have 0, -2, which should be this one here. And we have -1, -1, should be this one. Then we have 1, -1, which should be this one. Then we have -2, which is this. And we have 0, 0. Then -1, 1, which is this. Then we have 1, 1. Then we have 0, 2, which is this one. Then we have -2 and -2, which should be this one. And we have +2 and +2, which should be this one. What else? That's it. So this should be the pattern. But this is probably missing, right? This should be positive 2, 0. Positive 2, 0. That's something I somehow missed. It feels like I have missed a lot. Like also this one. And this one here. No. -2? -2, 2. Yes. It should be like this one. If I'm not mistaken. Maybe if you know a better solution, let me know in the chat so I can correct it. But I will continue now. Okay, so now we have another pattern, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 1, 2. Okay. So this should be, if I'm not mistaken, let me check, 5, 10, 25, -1 would mean that, let's delete those 2 rows, and 4. This should be fine. Okay, now let's put in the magic numbers. -2, -2, -2, -1. Then we have -2, -0, but I will leave it out. Then we have -2 and 1. -2, 2. Then -1, -2. -1, -1. -1, 0. -1, 1. -1, 2. Next, a 0, -2, 0, -1, 0, 0, 0, 1, 0, 2, 1, -2, 1, -1, 1, 0, 1, 1, and 1, 2. Next, 2, -2, 2, -1, 2, 0, 2, 1, and 2, 2. Okay, That's a lot. I will actually not do that. Oops. Press something. To do if spare time. Okay, pattern 8. We'll still add the numbers here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1. Okay, so that's easy. We need to just delete those 2 lines and we should be okay. Okay, let's put in the numbers. 0, -2, -1, -1, 1, -1, -2, 0, 0, 2, 0, -1, 1, 1, 1, 0, 2, -2, -2. Next we have -2, 2, 2, -2, 2, 2, -3, -1, -3, 1. Then we have 3, -1, and oops, 3, 1. What is happening? 3, 1. Okay, this should be correct. Then 1, -3, -1, -3. Then 1, 3. And the last one is -1, 3. Okay, now we have pattern number 9 at index equals 8. So this pattern is actually the one we want to use here. So it is the pattern used in DSO's paper. And now it will get interesting because now we have quite a lot of pixels here. It should be okay. It's sufficient to use those pixels. In the original code base they also have 2 additional columns, but we will not need them, so I will leave them out here. And now let's add the pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9. No, only 8. So we need to remove 7 from here. 1, 2, 3, 4. 1, 2, 3. Okay, now we should be even again. Now this is 0, minus 2. Negative 1. Negative 1. 1. Negative 1. Negative 2. 0. 0, 0. 2, 0. Then negative 1. 1. And 0, 2. Okay. Let's put in the pattern and let's see if we get the same pattern as in the DSO paper. Okay, so now we have 0, negative 2, which means we are here. Then we have negative 1, which should be here. Then 1, negative 1 should be here. Then we have negative 2 and 0, which should be here. And 0, 0 is here. 2, 0 is here. And we have negative 1 and 1, should be here. And 0, 2, 0, 2 should be here. And this is actually not the pattern that was that is written in the original code base, but it's different. It's like that. This one is filled and this one is open. And this could be due to the flipped y-axis that I mentioned before, which I'm currently not sure because we haven't implemented the dataset loader yet. Or the dataset reader, I mean, this one here. And therefore, I'm not sure, but probably the y-axis is flipped in the code. Or the images are stored in a different way. Okay, but this should be the pattern that is also included in the DSO paper by the author Jakob Engel et al. From I think 2018, depending on whether you have the journal paper or the conference paper. Okay, now the last pattern, we need to add this as well. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, and weirdly enough, the other values are not minus 100, but minus 200. That's very unfortunate. But I will not change that, so I will remove those. And 4 lines as well, or 4 entries, I mean. So this should be it. And now I will add the numbers, minus 4, minus 4, minus 4, minus 2, minus 4, 0, minus 4, 2, minus 4, 4, minus 4, 4, minus 2, minus 4, minus 2, minus 2, minus 2, 0, minus 2, 2, minus 2, 2, minus 2, 4, then we have 0, minus 4, 0, minus 2, 0, 0, 0, 2, 0, 4, 2, minus 4, 2, minus 2, 2, 0, 2, 2, 2, 4, and we have 4, minus 4, 4, minus 2, 4, 0, 4, 2, and lastly 4, 4. Okay, and we have minus 200s here in the last remaining lines, but as I said, I will not change that. And this pattern is also a to-do for spare time. What can be better done with spare time than adding those pattern illustrations? Nothing, right? Okay, let's delete this extern keyword here. And let's fill up those arrays. So this is equal to the curly braces, and then this is as follows. Let's add a comment. This is the pattern number, and this is the padding. So the pattern numbers are 1, 5, 5, 9, 9, 13, 25, 21, 8, 25. Which should come out to the exact number that we have put in here. So if we count that, this should be 10, 10, and 5, 25. So this is correct. Here in this pattern, we can see this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 entries here, and so on and so forth. So this is the total number of used pixels, let's say. For the padding, we also need to define the array. And this consists of a 1, 1, 1, 1, again a 1, then we have 3 times the 2, and then we have a 3, a 2, and a 4. So this is the padding. Which I do not understand at the moment. Padding is usually how we want to fill up this neighborhood. So probably the padding will add a border of pixels. But we will know when we come to the part where this is used. So let us keep that in mind. There are not an awful lot of things to keep in mind at this point, but it's getting more and more complicated. So at some point it would be good to have a drawing or a concept of the whole framework. Yeah. Okay. This can be deleted. And we are really finished with the Settings.cc file. A lot of stuff, really a lot, which also gives you a rough idea of how the LDSO is working, what is used, what kind of parameters we can play with, and yeah, this should be a good overview. I think it was a good idea to finish the settings file now, so that we are mentally prepared for the hard stuff that is coming with the final implementation. And maybe it's a good reference to go over that again, think about what is defined here and what kind of impact it could have. Okay, let's quickly try to compile the project again. So it's compiling. I hope I have saved everything. And if I run it, it should not be a problem. Run. Okay. It's finished already. And everything is good. Now we can go ahead and try to get rid of some of these. We can try to get rid of some of these to-dos here. So let's see. We do not have the front end yet, so we can skip this for now. We're using the namespace LDSO. Okay, now we have to get rid of those to-dos because this is something we should have. Yeah. And this one as well. These ones. It's really looking nice if we can, or when we can remove those to-dos. Just makes it just has the feeling of being more complete. Okay, now we have this setting here. It's a nice feeling to remove those to-dos. Disable ROS, disable reconfigure, setting log stuff should also be available. These ones as well. Now we can set this setting and this one. And we can probably also see out that we have loop closing enabled or disabled. Here, debug save images is true. Yeah, we cannot fix this one. This is shipped with the LDSO. Then we have those to-dos. Now we can see if we have some typos. Let's put on some music. Okay, this is about that. Now we can also remove these to-dos. Okay, unfortunately we do not have the image folder reader yet, so we cannot uncomment that. And we do not have this reader defined, therefore this cannot be done now. And next is the reader, orb vocabulary. I think this is it for now. Well, we can do this one here. If preload. Okay, so this is the segmentation fault here. We need to fill up the IDs to play. But we can probably use this now. tmlog. tmlog. This is the reader. Why is this an incomplete type? Probably because it's not initialized. But why is that? Let me check. tmlog. That's okay. Unfortunately, I'm not sure about this error at the moment. Well, let's keep it for later. And we cannot add anything else. Okay. Now let's try to compile it again. Still compiling, and it's running. Okay. So now the settings should be finished by now, even though it was a lot of work. Well, it was not a lot of work, but a lot of writing. Okay. Now we can see if we can implement the dataset reader. And as this is only a header file, I would say we'll try it now as well. So let's close the Settings.h. Well, let's first add a pragma once in the beginning as well. I want to include it only once, this header file. And we also want to add it into the dataset reader. Okay. Now, let's go through this dataset reader. We have the Settings.h file, which we will use throughout this implementation of the dataset reader, but we also need some other includes. The first one is the S stream, and we also need the F stream. We also want to include the Direct.h file, and we also want to include the algorithm, and we also want to have the boost library. Format.hpp. Next we have our own includes. This will mean that we have a to-do, because we also want to include other parts, which is, for example, the front end undistort.h. We also have a front end ImageReadWrite.h, and we also have a front end image and exposure.h. And we also have two more includes from the internal directory, which is the global funcs and the global calib.h. We do not have them. Oh, it's from the internal as well. We do not have those files, of course, so we will leave them out for now and work with the to-do as we did before, until hopefully everything comes together. Okay, so now we need to have a preprocessor directive, which is the if has ziplib, which means do we have the zip library? If we have it, we want to include it. Zip.h, and now we end the if statement. Next we also include the IO stream, and this is about the includes here. Not sure why it shows me that I do not have the ziplib. Probably because it's missing here. Now it should be loaded from disk. Okay, let's see if it works. And if... now it's okay. Maybe it needs some time to organize itself. Anyway, we need to use the namespace std, and we also want to use the namespace LDSO and the namespace LDSO internal, which we do not have at the moment, but maybe it will be defined at some point. No, it's not defined at the moment in this file, so let's add it as a to-do. Okay, now we can start with the implementation. But before we implement the class, for the dataset reader, we need to define functions, some helper functions, let's say. Helper functions for accessing the file system. Helper functions. The first helper function is an inline integer getDir, which expects a directory as a string and a vector, standard vector, of strings, which are the files. And here we want to get a dir object, a pointer, a dir pointer, and we generate a struct with the dirent, the directory entry probably, dir p, and if the directory pointer is equal to open dir, and then we take the dir and the c string, and if this is null, so if we cannot open the directory, so if the dir pointer is null, we return -1. Let's say cannot open directory. Next, while our dir pointer is reading the directory, so basically, do we have a directory entry? Then we loop through this directory, which is the standard string name, standard string from dir p, and then dname. Then we check if the name is not equal to the current directory, and the name is not equal to the parent directory, and name substring, name size -3, name size is gleich equals to JPEG. sorry about that. Then we want to have a files object, pushback name. So the files are passed here, and we are getting, or we are looping through the through the directory, listing all the files, and we are looking for file names which end with the JPEG extension, yeah. Add files which end JPEG extension. Okay, after the while loop, we close the directory for the directory pointer. And next we begin to sort. sort files.begin and files end. Now if the directory at the length of the directory -1 is not equal to the slash, then I will do the new line here. Dir is equal to dir plus the slash. So we basically add another slash. Dir at dir length is not equal to maybe this should be a character. We are not in Python here. Okay. We are comparing characters and strings, which is not the same. But here this is fine, because we are adding a string to a string. Okay. Next we do a for loop. Unsigned int I equals 0. I is less than file size. And I plus plus. Oh, sorry, you cannot see it. Okay, for unsigned int I equals 0. So we basically loop through the files object, which contains standard strings. And what do we want to do then? We want to check if the files at the position I at 0 are not equal to the slash. And if this is the case, then we want to manipulate the files object at position I to be equal to dir plus files at position I. So if this is basically not the current directory, in the beginning, so at 0, at the first position, yeah, it would be nice to print what is happening here, but basically it's adding the directory that we have defined in the beginning here, and added the file name, I think. It's probably the file name. So we are just reorganizing our file paths. And after that, we want to log an info that the file's size is file size and line. And we want to return file size. Okay, we are only returning the file size. So the number, okay, the files are saved here, call by reference, and we want to return how many files we got from that. Okay. This function loops through the directory, adds JPEG files to the files object and returns the number of files. Okay. Next, we want to have a struct for prep image item. This struct has an ID. It has a bool whether it is cute, and it has an image and exposure object pointer to that. And unfortunately, we do not have this object, so we will later add it to. But for now, I want to define an inline prep image item, which takes an ID and an inline void release. And a prep image item, which does not have a type. Ah, okay, it's the constructor, I see. ID equals ID, is cute equals false, and the pointer is 0. And for the release, we add the if condition if pointer is not equal to 0. Then we want to delete the pointer and set pointer to 0. Okay. Unfortunately, we need to comment out everything. But we still have the prep image item prepared here without the image and exposure. So we need to add that later. Okay, but now we can get to the important part and add our first class. Class ImageFolderReader. And this will be the happy ImageFolderReader that we will use to read in our dataset. Okay, so we have the public scope here, which will contain an enum for the dataset type. So we have different types of datasets. You can see that here in the beginning of our main function, that we no, wait a second, in the CMake lists, yeah. In the CMake lists, the original code base of the LDSO implements 3 different types of examples for Tomono, Oirok, and Kitty. And those are the data sets we could usually load. So therefore we can define a dataset type, which can either be Tomono, or Kitty, or Oirok. And we will use the Tomono dataset. Which means that we could also skip implementing the Kitty and Oirok specific stuff, but it's maybe a good idea to leave it here for the ImageFolderReader in case we want to add it later, and for, of course, seeing the differences between the Tomono dataset and the other datasets. Okay, so next we need the constructor ImageFolderReader, and this will take in a dataset type as defined before, just a dataset type. Then we have a standard string for the path. We have a standard string for the calip file. We have a standard string for the gamma file. And we have a standard string for the vignette file. Okay, and in the constructor body, we will say this with an arrow. Dataset type is equal to dataset type, and this path is equal to path, and this calip file is equal to calip file. But that's not it. We also have a preprocessor directive, which is given by if has ziplib and an end if. If we have a ziplib, then we set zip archive to 0 and the data buffer to 0 as well. Next we check if the file is zipped. This is equal to path.length is greater than 4, and path substring path length minus 4 is equal to .zip. So we check the extension once again and define this is zipped variable. This is zipped variable will be defined later as a member variable of this class. That's why currently it's marked with this squiggly red line. Okay, if the dataset type is equal to tum mono, and if the data is zipped, we need to check if we have the ziplib. So once again, we copy that part here. And say if we have the ziplib, then if zip error, no, not if, but int zip error equals 0, the zip archive is equal to zip open path dot c string, and we have this constant zip rd only, read only, and we pass the zip error so that it can be filled by the method. Next we ask if the zip error is not equal to 0. Then we print, or let's say we see out Do we have the standard namespace used here? Yes. Cout error and the error is the zip error. Reading archive path C string and an end line. So this should be it. And then we want to exit the 1. If we pass that here, then we get to clear the files. We define an int with num entries to be zip get num entries for the zip archive 0. Then we loop through int k equals 0. K is less than number of entries. And we increment k. And for every loop, we get the const char pointer name. It's equal to zip get name zip archive k zip fl enc strict and we get an end string. It's equal to standard string name if end string is equal to the current directory or end string is equal to the parent directory, then we want to continue, and after that we want to take the files and push back name. Next we want to see out. There we got num entries. Entries and int file size files and an end line. And then we want to standard sort files begin and files end. Okay, now we have an else block here as well. Because if we do not have ziplib available, then we log a fatal message which tells us error. Cannot read zip archive as compile without ziplib exclamation mark and new line semicolon. Good. Okay, if it's not zipped, so if it's zipped, we do this part here, and otherwise else we get the dir, get dir for path and files. So this is already where we are using our helper function from above that we have written before. So here we are actually going through the directory and putting back or returning back the files object, which we can later use for stepping through the files and reading them and so on. Okay, next we want to have an undistort, which is equal to undistort and then colon get undistorter for file, calip file, gamma file, vignette file. So this is something we do not have at the moment. The undistorter, we need to write that, but it will not be instantiated here. Well, probably it will. It will return an undistort object, and then we can do something with the undistorter. For example, we can get the width org, which probably means original, which is undistort, and then get original size, but from this the first element. Then we get the height, and we have the width and height below here. So the undistorter gets the original size, but the height is the second object, so it's the one here. And for the width, we get undistort, not get original size, but get size. With 0 and 1 again. So we will have an original size, so the full resolution of our images, but we will also have the width and the height that is specified by scaling down the images. Or it could also happen that the undistorter will create a smaller or larger image for us, depending on what the calibration is. So we will need to take all of that into account. Usually we have an original size and a final size. Okay, next we load the timestamps if possible. So if the dataset type is equal to mono, then we want to load timestamps. What about the other dataset types? Else if and else if. The dataset type is UROC, or the dataset type is Kitty. Then we want to load timestamps UROC or load timestamps Kitty. Okay, after this being the constructor of the image folder reader, we will now use or define the destructor. So image folder reader and here once again we need to check for the has ziplib because if we are loading the zip-lib, then we need to pay attention to close it as well. So if we have it, then if zip archive is not equal to 0, so if it's set, then we want to call zip close zip archive. And also the data buffer, if the data buffer is not equal to 0, then we want to delete the data buffer. And anyway, unrelated to the zip-lib, want to delete the undistorter. Now we need to define some methods. Helper methods. That is, from eigen, we expect a vector with x dimensions, and the method is called getOriginalCalib, which should return undistort get original parameter casted to a float, and also a method called eigen, or returns an eigen vector to integer, get original dimensions, dimensions, return undistort get original size, this declaration has no storage class. Weird. Okay, next we need to define another method which returns void getCalib mono eigen matrix 3f. We get the calibration matrix, the intrinsic parameters, the integer about the width, and the integer about the height. Maybe I forgot a semicolon. Yes, okay, that's it. I forgot a semicolon here. That's why it's throwing the error, I think. Next, getCalib mono. This will set the K matrix, the width, and the height, which is equal to the undistort get K casted to a float. Then we get the undistort get size, zero, and get size 1. And now let's turn on the music again. get calib mono. So this will set our calibration for the monocular camera. We also have a method called set global calibration. Which defines two integers, one w out and an h out. There's also an eigen matrix 3f calibration matrix, and we then call the get calib mono with k, w out and h out. Set global calib with w out and h out and k. So there's not only a set global calibration, but also a set global calib we need to implement. But before that, we define an integer method which gets us the number of images. Which returns file's size. Then we also need the method for getting our timestamps and ID. If timestamps size is equal to 0, then we want to return ID times 0.1f. So if we do not have timestamps, then we are just incrementing based on the ID. So ID is, if it's 0, then it's 0. If it's 1, it's 0.1, then it's 0.2, and so on and so forth. If the ID is greater or equal to the integer timestamps dot size, then we want to return 0. Let me skip that music. Oh, it's finished anyway. Okay. Then after that, we check for if the ID is less than 0, in which case we want to return a 0. And if all those checks have passed, then we want to return the timestamps at the ID. Okay, next we want to prepare our images, which is weirdly enough just an empty method. I will add it anyway. Prep image with the integer ID, a bool as 8 unsigned, 8-bit unsigned integer is false. It's a standard parameter, but this is empty. Next, we are returning a minimal image, B, a pointer to it, get image raw with the ID passed. Lets us return get image raw internal with the ID and 0. We can also return an image and exposure pointer by naming it getImage, int ID, bool force load directly is false, which returns getImage internal ID 0. Image internal. Next we have inline float pointer for get photometric gamma. If undistort is equal to 0 or undistort photometric undist equals 0, then we want to return 0. Else we want to return undistort photometric undist get G, which is probably gamma. Ah, not probably, but it is the gamma. Okay. Next we have in this public scope, I think. Yes, in this public scope we have a member variable which is called, or which is from the type undistort, and it's a pointer to the undistort object. Next we have a private section which contains a few methods and attributes. For example, the methods that we need here is to load a minimal image B pointer by calling getImageRaw internal. So this is not exposed in the public scope, but only in the private. And we pass an ID and an integer unused. Here we check if the file is not zipped. Then we return IOWrap read image black and white 8-bit unsigned files ID. So we take from the files at the position ID, we take the file name, and from this file name we want to return an IOWrap black and white image. But if it is zipped, so else, again with the preprocessor directive, if has ziplib, let's get rid of that, and let's say if the data buffer is 0, then we want to initialize the data buffer. data buffer is equal to new char width arc times height arc times 6 plus 10,000. Then we define a new, but this is done outside. Outside the if condition, we will define a zip file type FLE equals zip or fopen. We open a file, a zip archive, files at the id.c string 0, and we get a long data type for read bytes or for read bytes. It's equal to zip fread FLE data buffer along of width arc times height arc times 6 plus 10,000. Then we check if the read bytes are greater than long width arc times height arc times 6 . And if this is the case, then we see out what we have read. Read read bytes of long width arc times height arc times 6 plus 10,000. And then bytes for files id dot c string dot increase buffer exclamation marks, of course. So after printing this, let me add some new lines here. We delete the data buffer array and initialize it again. Data buffer equals new char long width arc times height arc times 30, and FLE equals zip fopen zip archive files at the id c string 0, and now we override the read bytes equals zip fread FLE data buffer long width arc times height arc times 30 this time plus 10,000, and now the buffer should be big enough. So that we can now check if the red bytes are greater than long width arc times height arc times 30. And if this is the case, then the buffer is still too small. So we see out again. Buffer still too... Okay, in the original code base it's written too small, but it's probably too small. Read or read probably, then read bytes of long width arc times height arc times 30 plus 10,000. And end line. I think I forgot an end line up here. Okay, and then after printing the error message, we just want to exit. And after that, we return the IO wrap, read stream black and white, 8U, data buffer, red bytes. Okay. Now, before ending this if here, we want an else block, which tells us that, wait a second, I think we have it already. Like here. Let me quickly check. Okay, that's fine. So let's copy this part here for cannot read zip archive as compile without ziplib, and add it here into this else block. But we will also add an exit one here. Okay, that's about the what's it called, the minimal image B. Next, we also want to return an image and exposure. With the pointer by calling get image internal with an int ID and an int unused. We'll create a minimal image B min img equals get image raw internal with the ID and 0. We get an image and exposure ret2 is equal to undistort of type unsigned char. So after getting the min img, the minimal img, we pass it to the undistorter and we tell him, hey, we have an unsigned char here. Unsigned char, which is stored in min img. And we give you the following exposures. Exposure size. We ask it if it's 0. If it's 0, then we pass 1.0f. Otherwise, we pass exposures at ID. So this is the first the second argument of the undistort method, and the second one is almost the same, but this time with the timestamps. Timestamps size, and if we do not have timestamps, then we pass a 0. Otherwise, of course, we get the timestamps array and pass that. After that, we delete the min img and we return ret2 because we want to return the image and exposure. And to be honest, I'm not happy with the name ret2, so I will call it img_xp because it's a local variable anyway, and return that here. Okay, it is a bit chaotic, but now we need to load the timestamps actually. So what we will have here are 3 functions: inline void load timestamps uroc, and we will have the same for Kitty and for the Tomono dataset. Now let's implement all of the methods by writing log of info loading uroc timestamps end line. Then we create an if stream, input file stream, and a standard string times file equals path plus data CSV. So this is hard coded here on the data CSV, so it needs to be provided. Next we have this if stream, and we open it using the times file C string. Then we check if tr is not available. If it's not available, and then we log an info. Cannot find timestamp file. Something may be wrong in dataset setting end line. We also log the info about the times file end line. And then we return. So if nothing has happened until that point, we are safe to go through the times file now. So in this tr, timestamps for UROC, we have loaded the timestamps. Now we can get through the lines. So we have loaded the file, while not tr end of file and tr is good. Then we start the loop. We first store the line, standard string line. We also need a character buffer. Then we call tr get line into the buffer with 1000, the size of 1000. Then we create a stamp double variable, and we define the file name with 256 maximum characters. Next we check if the line at character 0 is equal to a comment file, a comment character like this one. Then we continue. So we basically skip the comments in the file. But if the scanf method or function returns a 2 for the buffer and the percentage lf comma percentage s, which will get us the stamp and the file name. Oh, I used this as a string again here. This is wrong, so this should be corrected now. So if we read in a line into the stamp and file name variables, if this works, so if we get 2 variables back, then we fill the timestamps array with pushback stamp times 1e minus 9. So we multiply the timestamp with a factor to convert probably from seconds to nanoseconds or microseconds. Probably to nanoseconds, I think. So timestamps push back and files push back as well. Path plus data plus string file name. Those variables are not defined yet. We will do that below. But for now, we can close the input file stream. Close. And we can log an info what we have done, which is load, total, timestamps, size, data entries, and line. Okay, so this is what is happening when we load the timestamps of the UROC dataset. Now we will copy that code and add it to the Kitty timestamps. And now we need to change a few things. First of all, we are loading the Kitty timestamps. Next, we want to open not the data CSV, but the times.txt. And we also want to check if we can open the file. And if we cannot open it, cannot find timestamp file at, now we print the path plus times.text, which is weird because we could just print the times file, but whatever, I will leave that now. And we end the line. We do not want, here it's printed a times file. Well, it's a bit messy, I'm sorry about that, but that's how the original code base is. I think later, when we have finished this whole project, we can later go ahead and confidently fix all of the weird things and the things that are probably buggy. That's the reason why we are doing this in the first place, to understand where the errors are and to understand how it is working. Okay, next we need to check that. We will not get the line in this case, which is very weird. Now we get the line into the buffer, and then we check if the buff 0 is equal to 0. We get rid of the file name, but we keep the double stamp. But in this case, if buff 0 equals 0, then we break. We do not continue, but we break. And for the stamp variable, we initialize it with @of convert a string to a floating point number. So we want to convert the string buff into a floating point number, which will equal the stamp. And then we will at some point push back into the timestamps array. But before we do that, we check if standard is none, stamp, then we break. Otherwise, we push back the stamp without a factor. Can you delete this if statement here? And we close the file. Then we need to do something else, which is new, which is that we need to get the files with a boost format fmt %s image 0 and then %06 d.png. So this is the structure of the Kitty dataset. It has several images, images 0, image 1, probably 2 other ones I think, which are placed on top of a car that is moving in Karlsruhe, for example, and these images are loaded with this, or this is the format that is used to load the images. And now for the size type, I equals 0, I is less than timestamps size, and I plus plus. Files.push back fmt modulo path modulo I dot string. This will be pushed back into the files name, into the files data structure, I mean. And after we have done this, then we can print load total, timestamp size, data entries, and okay. This is about the Kitty dataset, which we will not use unfortunately, but we will now use this function, the load timestamps, for the Tomono dataset. So let us once again copy the content of load timestamps Kitty and paste it here, load timestamps. And now we are changing the code to load the Tomono dataset. Let's leave it here with log info loading Tomono timestamps. This is not included in the original code base, but I find it quite useful to know what is happening. Then we have an ifstream tr and a times file, but the times file is now path.substring 0 to path find last of the slash. I really need to pay attention about the character and string difference here. I'm very used to Python at the moment. Plus times.txt, and then we open the file. Then we check if it is open. Then if it fails, then we want to try last directory. So we say times file is equal to path.substring 0 to path.find images plus times.txt. And we log an info where we say that we are trying trying, and then times file, handle, then we close, and we open times file.c string, and not return. Okay, while the end of file is not reached and the file is good, we here once again introduce our line, standard string line. We keep the buffer of 1000 characters. We get the line into the buffer. Then we check, we do not check, but we define an integer with the ID, a double with the stamp, and a float with the exposure, which is 0. Then we check if 3 equals scanf, the buffer. So we check the buffer for an integer, %d, and %lf float, and a %float, where we put in those data types into and ID, and stamp, and exposure. Yeah, and if this is successful, then we can add to the timestamps array, push back, stamp, and also the exposures, push back, exposure. If we have those 3 variables, then it's fine, but what if we only have 2 variables, scanf buff, then %d and lf, and we have the ID and the stamp, but no exposure? Then we still do the same with the stamp and the exposure, but the exposure will be 0 here in this case. Next, we delete the rest and we close the file, and then we log an info. After we have closed the file, we log info about the files, colon, which is the files size, and also the timestamps, which is the timestamp size. But then we also have the exposure size, which will be called here exposure times. And that's it. We end line, and this should be it. Exposures.size, exposures. Okay, then we need to check if the exposures are correct. Let me turn on the music. Check if exposures are correct. and possibly skip. Bool exposure, exposure's good, is equal to cast to integer, exposures size is equal to int get num images. So we check if we have the same number of exposures as we do with the number of images. Then we loop through the exposures. Int I equals 0. I is less than cast to integer exposures dot size, and I incremented. We check if the exposures at index I, if this is equal to 0, then we fix. So we have found an entry which is 0, and an exposure time of 0 is weird. Will be a very fast camera. If we want to fix it, then we store a float for sum equals 0 and num equals 0. And we check if I is greater than 0 and exposures at index I minus 1 are greater than 0, in which case we increment the sum by exposures I minus 1 and num plus plus. Next, we also check if I plus 1 is less than integer of exposures dot size and exposures at I plus 1 is greater than 0. Then we increment sum by this time exposures I plus 1, and we increment num. Next, we check for the number. If this is greater than 0, then we need to update the exposures at index I to be equal to sum over num. Okay, and after that we add a second check into the for loop, which checks for the exposures at index I. If this is equal to 0, then we say exposures good is equal to false. Unfortunately, we didn't fix the exposures. And let's add this comment here. Have we fixed the exposure value? No, wait a second. We have not fixed the exposure value. So we need to notify the rest of the code. first we check if cast to int get num images is not equal to int cast to int timestamps.size. So this basically means that number of images does not match number of timestamps. Therefore we see out set timestamps and exposures to 0. And line exposures dot clear and timestamps dot clear. Okay, now we are missing this get num images method, which we will implement now. No, I'm mistaken, sorry. We probably have it already. Ah yeah, we have it already. I'm a bit confused, but now everything is clear. Now we have checked the num images with the timestamps. Now we need to check the same, the number of images, with the exposures. Size, which is a bit weird because we have cleared the exposures. Okay, those are two different checks, so it's fine. Exposure size or not exposures, good. So this is the other condition we need to check. So number of images does not match number of exposures, or exposures bad. Then we need to print set exposures to 0. And line exposures clear, and this is this part. And after that we want to see out something, namely how many images and timestamps and exposures we got. So got cast to int get num images and cast to int and cast to int timestamps size timestamps got num images and timestamp size timestamps and int exposures dot size exposures, and then end line. Okay, this is it with this method, but I would say I like it a lot better if we log the info and not a simple cout, so that it looks nicer. With this log info we will have the line number that is used for printing this line, whereas with printf we do not have the line number, and therefore it is easier to use the log info for debugging. Okay, now within the dataset reader, the ImageFolderReader class, we want to add member variables, private member variables. For example, we want to add a standard vector of type image and exposure pointer, which is called preloaded images. We also want to have a standard vector of type standard string for the files, and a standard vector of type double for time stamps, and a standard vector of type float for the exposures. And we also need a dataset type, which will store the dataset type for us. But that's not everything. We also need to have an int for the width and the height, and the same for the width original and height original. Next, we also need a standard string for the path and a standard string for the calip file, and a bool for is zipped. And we also need, in case we have a zip file, so if has ziplib, I will copy that from here. We also need that zip archive variable and the data buffer variable, which we have been using. So the zip archive is of type zip underscore t and then pointer, zip archive. And the data buffer is of type char pointer data buffer. And of course we need to have a semicolon at the end of the class definition. And now some of the errors are gone, but still we have quite a few left. We have the image and exposure, which is not defined yet. We're using the getNumImages, which is not defined, getNumImages, but it is defined, so this is weird. This is somewhat weird. Should be defined usually. Okay, here we have the minimal image, image and exposure, which are not defined. So we cannot use it, unfortunately. This is again minimal image. IO wrap is not defined. Undistort and eigen are the problem here. What about the constructor? Does it have to end with a semicolon? No. This is interesting. The constructor does not end with a semicolon, but the destructor does. Okay, now it's time to check for the errors. Maybe I have a typo. ImageFolderReader. Oh, I missed the semicolon after the enum here. That's the problem. So let's add this. Should fix a few errors. There is an expected semicolon somewhere. Now bear with me until I find all the errors. Okay, so this is clear. The undistorter, we do not have the undistorter yet. So I will mark this as a to-do. There's no other option. That's why I also have to mark this as a to-do, which is following here. Next, I cannot delete the undistorter if I do not have it. Now what about the eigen here? Expected a semicolon. I'm blind. Where? Semicolon. ImageFolderReader. Okay, there's the undistorter here anyway. Cannot use those methods. So let's comment them out. Here as well, cannot use the undistorter yet. But why is this not working? Global scope qualifier. I'm actually not including the eigen library. I think the eigen library is included somewhere else, which is throwing me a lot of errors in this case. Maybe I can try to add it. sure how to write it. Let's for now just comment out the parts that are problematic. All of the happiness from the beginning is gone. Commenting out all of these parts is really frustrating, but it is something really normal for this stage of development, I think. This is the undistorter, which is not available. And then we have this minimal image B, which will probably be the next kind of data structure we will implement. Okay, the same with this one here. Timestamps should be fine. This is just a pure image file system operation. Now we have the image and exposure array. Almost there. This is the undistort. Okay, there's one error left with this class. Where is... Ah, here. There's the semicolon missing probably with the struct. Okay. Whew, okay. Let's see if it is really okay. Currently it does not look like we have errors left, but now we can test it. And with testing, there's always something unexpectedly happening. No, I'm not sure. Let's see. So let's clear this and let's call make project. Oh, it has a compile error with a data buffer. Expected a pointer. Data buffer was not declared. If it wasn't declared, it should not be using it. Char pointer. This is probably a typo. I think 561. 561. Yeah, that's a typo. It should be a semicolon, of course. Now let's recompile. Okay, now it's working. And now let's try to run it. And it runs. Okay. Let us check if we can get rid of some to-dos here. At least we have the reader now. So we should be able to construct a shared pointer now, which is called reader. Do we have imported it? I think we did. Now, reader set global calibration. This can probably fail because set global calibration is not available due to the getCalibMono method, which uses eigen and the undistorter. So this is okay for now. This will be a to-do until next time. And what about getPhotometric gamma? Can we use it? GetPhotometric gamma? We can at least use it. Okay. If it's 0, then we have an error. We can test if it will log the error. So we comment in this part. No error. Let's compile. Make project. It compiled. Let's run it. Yes, we have an error. Don't have photometric calibration. Need to use command line options mode equals 1 or 2. Okay, let's check if we can change the mode. So it's a little bit of debugging now. Preset mode. Let's use mode 1. Oh no, mode. That's a different thing, I think. Preset is 0, but let us check the mode. Mode. Quiet mode. Here's the mode. Okay, with calibration is mode 0. And we want to use mode 1 or 2. So we need to set mode. Therefore, let's add it. Mode equals 1. Let's see. Now we do not need to compile, but only run it. And yes, it has loaded 3000 timestamps. Is this correct? 3000. Could be correct. Let's go into the dataset. Sequence 45. Let's open the images. Do we have a total number here? But it's pretty much 3000 images from 0 to 2999. So it seems to work to parse the data. And we are also using the zip file, so now probably it has updated the dataset reader with the preprocessor directive. No, it has not. Weird. So this constant is not working. Or I am missing something. Okay, I would say after 4.5 hours, we should stop at this point. What I can say now is, if you did bear with me and watched me and maybe also programmed something, congratulations. I didn't think that. But for the next time, we will now start to fix the to-dos in this dataset reader by, I think, implementing mainly what is called the image and exposure and the minimal image as well, and maybe as well the undistorter. Maybe that's too much, but this is the plan for the next time. And at this undistorted part, we will get more into the methods and the maths behind the starting point of Visual Slams. That is how images are undistorted, what a camera model is, what a camera calibration is, and how we use it to, for example, convert fisheye images to pinhole images, pinhole camera images, and maybe other types of images as well. Okay, so I thank you very much that you have joined me. I hope it was a little bit of, interesting stuff. And I hope to see you next time. Until then, have a great one and see you next time. Goodbye.